looking at a layer on a map, we can look at what its coordinate systems are by looking under its properties. And this will allow us to see what the coordinate system is. So for example, this NAT 83 State Plane, South Dakota is reported here. An important thing to remember is that we're going to have our stored units of our data. So data can be in all these different coordinate systems. It's going to be projected on the fly into the coordinate system we've set for the map, the Oregon Statewide Lambert. So we have the stored units, that happens in the geodatabase. We have the map units, that happens on the map. And then it's going to tell us, it's going to display here, since this is in a Lambert conic conformal map projection, that's in meters for default. So that's going to display the meters here where our cursor is, but we can always change that if we want to miles or feet or any other sorts of units that we want. Part of this idea is that the data is stored in these coordinate systems, but there's also going to be a spatial reference associated with that. So in the geodatabase, we can actually look at the spatial reference. The spatial reference is going to tell us what the projected coordinate system is, and it's also going to have a geographic coordinate system associated with it. So in the spatial reference, it includes the storage units, the domain, which is kind of the minimum and maximum x and y's of where the data covers, and then the resolution, which is going to be how precise it is. So if we want to take one data set and put it into a new map projection, we have to do something called projecting the data. So this is a tool called Project, and this is going to be different than a tool we'll talk about in a minute right above here called Define the Projection. The project actually takes the coordinates and puts them into a new system. The define projection lets you change if there's some sort of mistake or error involved in it. So with this project tool, you'll actually be putting it into a new coordinate system. In this case, the output is going to be in Universal Transverse Mercator, Zone 13. And sometimes if you're changing datums, you're also going to have to define what the geographic transformation for that is. So when you do these sorts of projections, some issues can arise. Sometimes if there's a very large discrepancy from hundreds to thousands of kilometers, one data set is off from another data set, that's usually a problem when a projection is mislabeled. If there's a small discrepancy, like tens to hundreds of meters, that typically occurs when the datum is incorrect. So when that transformation with the datums, if you were unaware that a transformation happened, you might get that sort of error. And that's what we're seeing here, where things are off by a distance indicated by these orange arrows here. And very small discrepancies, they're usually just a result of some sort of accuracy. Maybe the GPS unit that the data was collected with wasn't as accurate as current units are. So if something is mislabeled in a coordinate system, as an example here, then we can fix that. And basically, it's kind of working with the metadata. We're not projecting the data, we're just redefining the projection. So we use this define projection tool in order to correct errors that have been made. And sometimes we have to go back to the people that gave us the data and ask about what projection it's in, or we have to try different things and see how we can get our data to line up. But this is not always an apparent thing, and of course, because someone made an error maybe before you got the data, something you have to do a little detective work for. But once you open up the Define Projection tool, you'll be able to edit these sorts of things and actually define the projection that you believe the data actually is in. So this is a way of fixing these incorrect labels. You're not actually projecting the data. You're just redefining what was incorrectly defined before. But in doing so, when the data is projected on the fly in the GIS, it should now come into its proper geographic location. So there's these two different tools. Once again, there's Define Projection tool and the Project tool. And the only time you should really use the Define Projection tool is when the coordinate system is missing or incorrect. That's really the only time. It does not change the coordinates in the file. It does not reproject the data. It just basically corrects a mistake or missing data that was already there. With the Project tool, however, you're doing something very different. You're taking something from one coordinate system, a layer from one coordinate system, and you're projecting it, you're doing a transformation of it into a new coordinate system. And remember, you might want to do this because you want to do analysis with that data and you want the distances to be correct, or you want to properly display population density and you want the areas to be correct. So here, you use this when you're changing a coordinate system permanently, and it's used to assemble collections of data with the same stored coordinate system. So you might put everything in the same stored coordinate system in order to do analysis with more than one data layer at the same time.